Hello everyone. In this video, I will introduce the new mix solver available in the Mechanical APDL product. I will share the basics of how it operates, why it was developed, and some of its key benefits. Ansys has been supporting several types of equation solvers through the Mechanical APDL product for over 30 years now, releasing both iterative and direct method solvers. And since 2010, the Mechanical APDL product has also been supporting GPU hardware to accelerate all of its equation solvers. The new mix solver blends the better characteristics of the direct and iterative solvers while also optimizing its performance for the latest GPU cards. So on the spectrum of equation solvers, iterative solvers here are on the leftmost side and the direct solvers are on the right side, and they both have their pros and cons. For the direct method solvers, their largest benefits are being very robust and always providing a result, and therefore it's the default solver for all types of analyses in the Mechanical APDL product. However, direct solvers use the most amount of memory relative to other solvers. And for the iterative solvers, their biggest advantage is using a lot less memory than the direct solvers, but their biggest disadvantage is simply that they do not always converge, and so they cannot be used to support all analysis types in the Mechanical APDL product. The new mix solver overcomes these challenges facing the direct and iterative method solvers. It uses less memory than the typical direct solver, and it has a better convergence success rate compared to the typical iterative solver. The mix solver also supports more GPU hardware, particularly utilizing workstation graphics cards to their fullest potential, specifically in regards to the high 32-bit or single precision compute rates. Now, the mix solver is still fully accurate, and this was vital when creating the new solver to not make any sacrifices in accuracy while improving its performance. So the mixed solver is shown here in the middle of the equation solver spectrum, somewhere between the sparse direct method solver and the most heavily used iterative method solver, the PCG solver. The mixed solver is positioned in the middle because it uses less memory than the sparse direct method solver, but more memory than the iterative solver. And the mixed solver also converges more frequently than the PCG solver, but is not quite as robust as the sparse direct solver. Starting in release 2025 R1, the mixed solver is available in the Mechanical APDL product. The mixed solver gets its name from being a mix of both the direct and iterative solvers, along with mixing various floating point precisions and computations on both CPU cores and GPU cards for acceleration. You can activate the mix solver by using the EQ-SLV command, as you normally would any other equation solver in the Mechanical APDL product. And for further details, you can refer to the documentation. The mixed solver uses a variety of floating point precisions and GPU cards to accelerate its computations. The two main GPU card classes are data center and workstation cards. The data center cards are typically very expensive and often difficult to purchase due to their limited supply, primarily because of the high bandwidth memory on each card. These cards usually come in double precision FP64 to single precision or FP32 computation ratios of 2:1. Now by contrast, workstation cards are extremely easy to obtain and relatively affordable compared to the data center cards. Workstation cards have a much different double precision to single precision computation ratio, often 16 to 64 times faster than double precision computations, assuming the calculations are done using the lower precision. Here's an engine block benchmark that shows the performance advantages of using the mixed solver with various GPU cards. The benchmark is a nonlinear static analysis of about 4 million degrees of freedom using the latest release 2025 R1 software with the GPUs. Its baseline is running the mixed solver without a GPU. The first GPU used in this benchmark is the NVIDIA H100, which is a data center card. Running the mixed solver on this GPU leads to a 5x improvement in terms of the performance relative to the baseline. The second GPU in this benchmark is an NVIDIA RTX A6000 Ada, which is a workstation class card. Running the mixed solver on this GPU card is also extremely effective because the solver uses the GPU card's lower precision and high compute speeds. The data from this benchmark shows you that you can obtain nearly the same performance level with the more affordable GPU card compared to the data center card. With the same benchmark, we also compared the results of the mixed solver and the existing sparse direct solver on both GPU cards. And for the H100, which is the more expensive data center card, the solver performance performs approximately the same as the mixed solver. However, on the right, you can see that the RTX A6000 Ada, which is a workstation class card, and there the sparse solver ran significantly slower since it requires full double precision calculations, which these workstation GPUs do not offer. Meanwhile, the mixed solver effectively uses the high single precision compute rate on the RTX A6000 Ada card, resulting in a fully accurate solution that is equivalently fast as the direct solver, but on a more affordable workstation card. So in conclusion, the new mixed solver enables you to accelerate your computations with more accessible and a more affordable manner.